Hello team, this is 3 strikes where we're given an integer from 1 to 10,000. 10,000, we've seen that one before. And we need to return a count of how many of these numbers from 1 to that integer, whatever that argument is, once squared if they contain 3, right? So that's a bit of a mouthful. Basically what that means is we're going to roll up the count, right? We're going to do it. And we're going to square each number from 1 to whatever our selected number is, right? If that number has a 3 in it, then we add 1 to our count. So for 1, it's only ever going to be 1. 1 times 1 is 1. Can never have a 3 in it, so that's 0. For 10, it is the number 6. 6 times 6 is 36, which has a 3, so we increment and get 1, right? And so on, etc., all the way down to 10,000, which has 4,531, right? That's what we're going for. So in order to get this done, I mean, 10,000, we've seen that in recent challenges, right? Or we haven't seen it, sorry. I've talked about it, right? In terms of recursion. So let's try it, right? Let's try it with recursion. Right here, I'm going to set up a number. We'll just call it num, okay? And that number is going to be n times n or n squared, okay? Just like this. And then we're going to send that number to a string. So to string right here. And then we're going to check if it includes 3, right? That's the whole thing. So right here in quotes, I don't actually know if it needs quotes. I'm not sure of that, but I'm going to leave it in quotes. It feels about right, okay? If there is a 3, then num is 1. Otherwise, num is 0, right? So right there, we got it. And then we take that num, just like this, and add it to sum of squares, right here, n minus 1. Now, we do need that escape hatch, so let's do that. If n is equal to 1, or better yet, if n is less than equal to 1, then return 0, right? And again, we should probably have some errors in here, right? I've talked about that in recent videos as well. I'm going to skip it today, but at this point, it should error out, okay? If you're expecting it to work, well, it works for pretty much everything except our last challenge, right? Why does it fail on the last challenge? Well, for all the reasons that I've said before, here it is. Maximum call stack exceeded, right? We've hit it, and we hit it brilliantly, spectacularly, right? We've done the thing. So this is, again, I've mentioned that at some point recursion is going to fail you with this max call stack exceeded error, okay? And this shows that. So we need something else, which means that this, as pretty as it is, needs to go away, okay? Instead, we're going to do it just like we did yesterday and the day before. We're going to set up a loop, okay? So instead of all of this, we're going to get rid of this for a second and go let count equal 0, okay? And then from here, let I equal 1, because it makes no sense to start at 0, right? 0 is always going to be 0. That doesn't do anything, so I is less than equal to n, just like this, and I plus plus, just like yesterday's challenge, sending it in, and then we test it. What are we testing? Well, we're testing all the same stuff, so we can actually grab that, copy it, bring it right down, and if that's the case, then count plus equals 1. If you wanted to, you could go count plus plus. I like this for the clarity of it, right? It feels less prone to errors. Count plus plus, the way that it works, it can catch you, right? So be careful with that. Whereas count plus equals 1, it should never do that. With all that done, we return count, right? And what fails? Of course I failed on something. What did I get? Oh, because it's not n, it is I, right? Be sure that we get it. There we are, okay? So making sure that we're using the right variables, of course, right? And then, of course, testing everything to make sure that it has a 3, incrementing the count, sending it out the door. And this is a perfect example of how even though recursion can look very pretty and get the job done for a lot of different things, in this case, it fails hard, right? And that's because we do roll up to big, big numbers. So there it is. This is today's solution. And it's similar to yesterday's solution and the previous days because they're kind of on a pattern for this week. But let me know. Let me know what you think, or if you went a different way. If it surprised you to hit that max call stack, right? That they would actually throw that challenge in there, right? But if you can sort out the conditional in here, then this loop just works, and it works brilliantly, okay? So yeah, let me know all the good stuff that you're thinking about this. Comment on your solution, right? Let me know all that too. Otherwise, for today, this has been 3 Strikes, and I will see you in the next one.